Use transformations to sketch the graph of g of x equals 2 times the quantity x minus 3 to the fourth plus 1. We need to figure out how we can take the original equation, f of x equals x to the fourth, and transform that to end up with our new function, g of x equals 2 times the quantity x minus 3 to the fourth plus 1. So first, if we replace x with x minus 3, that gives us the quantity x minus 3 to the fourth. And we know this corresponds to a shift right by 3 units. Then we can take this function and replace it with 2 times the function. This corresponds to a vertical stretch by a factor of 2. And then lastly, we add 1 to our function. And this gives us a shift up by 1 unit. And this is our g of x equals 2 times the quantity x minus 3 to the fourth power plus 1. So we know that the original function x to the fourth contains the origin 1, 1 and negative 1, 1. We know that because it's x to the fourth and not x squared, it's generally growing at a much faster rate. It's much steeper, except in the interval from negative 1 to 1, where it ends up being even flatter near the origin. Anyways, let's go through the process of transforming this function point by point. First, we need to shift right 3 units. So if we take each of these points and shift them to the right 3 units, we're going to end up with these points right here. Then we need to do a vertical stretch by 2. The point that's still on the x-axis isn't going to move anywhere, but the other ones will be twice as far. So instead of having a y-coordinate of 1, they'll each have a y-coordinate of 2. And then we need to shift up by 1 unit. If we shift each of these up 1 unit, our new points will be there, there, and there. And so we need to draw a graph in a shape similar to f of x equals x to the fourth, but going through these points. And so it's going to look something like this. And like this. So this is a sketch of g of x equals 2 times the quantity x minus 3 to the fourth plus 1. Again, just a quick note, this is a very, very rough sketch. We've only taken 3 points from the original function and transformed them here. The reason is, if we picked another point that had integer coordinates, if we started off with 2, then 2 to the fourth power is 16. And when we stretch that vertically by a factor of 2, our point is going to be way outside the part of the xy plane that we have on our paper. So this is not going to give us the most accurate graph outside of these points, but it does give us a general idea of the shape of the graph, where the vertex is going to be, etc. So again, this is just giving us a rough idea of what the graph should look like.